The second goal of Chapter 9 is to compute depreciation using the following methods: straight line, units of production, and double declining balance. Depreciation is the loss of value of an asset over time. We record that periodically in relation to our fixed expense as depreciation. There are physical depreciation factors that are wear and tear or exposure to the weather that you can actually see the value becoming less. As if you were to resell it, you know you wouldn't get as much money because there are imperfections in it. Functional depreciation has to deal with obsolescence. You think about technology with this. Like the new iPad comes out. So the functional depreciation deals with the old iPads. They don't have as many features, so they still work. You can't see any marks on them necessarily, but they don't have the technology as the newer one does. Depreciation does not measure the decline in the market value of a fixed asset. So it really doesn't measure what you could sell it for, but it depreciates the value for you so that it does not have the value for you anymore. It does not provide cash to replace fixed assets as they wear out. Depreciation is a theoretical account. There's actually no cash changing hands. There's no amounts moving around, but we record it as a value on our books. So what do we factor in when computing depreciation? First, the initial cost. What did we buy it for? How long do we expect it to be useful for? And what do we expect it to be worth at the end of its life? Residual value is the value that a fixed asset should have when you are done with using it. We can estimate that when it's placed into service and then depreciate it according to how long we expect to have it. Here's a graphic showing the calculation of depreciation. Our initial cost, what we purchased it for, minus the residual value, what we expect it to be worth at the end. The difference between those two is how much value we have to depreciate. And that depreciation is spread up throughout the years of its useful life. So this item has a 5-year useful life. We figure out, for example, the initial cost might be $2,000. We expect it to be worth $500 when we sell it. So the depreciation cost is $1,500. We take that $1,500 and spread it out across the useful life of the asset. And the amount we spread across the useful life depends on the method that we use. Straight line method is the easiest method for depreciation and actually the most commonly used. To calculate it, we take the cost minus the estimated residual value, like in our example, if the cost was $2,000, minus the $500 we expect it to be worth at the end of its life, that's $1,500, divided by the estimated life. In our example, that was 5 years. $1,500 divided by 5 years would be $300 per year. That would be our annual depreciation. So straight line every year, if you graph this, would be at the same spot. It would always be at $300 for our example. We have an example here. Let's put in some numbers to visualize it. A depreciable asset costs $24,000. Its estimated residual value, what it'll be worth at the end of its useful life, is $2,000, and its estimated useful life is 5 years. So we have the formula up to refresh your memory. See if you can calculate the annual depreciation of this asset. Plugging in the numbers, you get 24,000 minus the 2,000, which is 22,000, divided by the 5 years of the expected useful life. Did you calculate an annual depreciation of $4,400? If you did, you're on the right track. If we use the preceding example and say it was purchased and placed into service on October 1st, the depreciation would be $1,100, computed as followed. Assuming that we are calculating it just for the year. So if we bought it on October 1st, we want to calculate the depreciation just for the rest of the year, October, November, December. So we would only need 3/12 of the annual amount. In the previous slide, we calculated $4,400 for the year, but this is only for October, November, and December, so we only are going to depreciate $1,100 this first year. Let's take a look at an example problem. We have equipment that's bought at the beginning of the year, makes the calculations easy, for $125,000 and a residual value of $5,000. an estimated useful life of 10 years. We have to figure out the depreciable cost, so how much is going to be depreciated, the straight line rate, and annual straight line depreciation. The only one we haven't done an example for is the straight line rate. That would be a percent. See if you can calculate these. A and C should be okay. Try B. Pause and attempt the problem. Let's see how you did. The depreciable cost is the purchase price minus the residual value. We are going to depreciate $120,000 for our asset in total. The straight line rate would be 10%. It's value or useful for 10 years, so we're going to depreciate 1/10 of its value each year, or 10%. The annual straight line depreciation, we are going to depreciate $120,000 over 10 years, or we can take $120,000 times the rate, we get $12,000. There's also another method called the units of production method. It provides for the same amount of depreciation expense for each unit produced or each unit of capacity used by the asset. So this depreciation is based on maybe the productivity of the asset, you can say. The formula is cost minus residual value, like our previous one, but this time we're dividing by total units of production, not its useful life. So not how long will we have it, but how productive will it be. We have an example here. The same asset, $24,000, residual value of $2,000, and this time we're not going to say how many years, but we expect it to operate for 10,000 hours. Lots of machinery is calculated on this way. So our formula is there. Can you calculate our depreciation per unit using the production method? If you plug in your numbers, you get 24,000 costs minus the 2,000 residual value, divided by the expected useful life, this time measured in operating hours, and you get $2.20 per hour that this item is operated. So the same example here, during the year the asset was operated 2,100 hours. We want to calculate the depreciation for the year. So if we take our depreciation per unit times how many units of production were used, we can calculate our depreciation. We calculated that our depreciation per unit was $2.20 per hour. It told us we used it for 2,100 hours. We multiply those together and get a depreciation of $4,620. That asset is going to be depreciated for a different value depending on how many hours it is used. Let's take a look at an example using units of production. Equipment is acquired at a cost of $180,000 within a residual value of $10,000. It has an estimated useful life of 40,000 hours, so being measured on hours again. It was operated for 3,600 hours during the year. We are going to figure out how much cost is going to be depreciated, the rate, and the units of production depreciation for the year. Pause and try the problem. For the depreciable cost, you take the acquired cost, how much you paid for it, minus the residual value, what's left. We are going to depreciate $170,000 from this asset. Our rate, we take $170,000 that we're going to depreciate over the life of 40,000 hours, so that's $4.25 per hour. If we take the $4.25 times the 3,600 hours it was used, we get $15,300 worth of depreciation for the year. The final method is the double declining balance method. The double declining balance methods provides for a declining periodic expense over the estimated useful life of the asset. So early on in the life, depreciation will be higher, and then it will decrease as the asset gets older, so it won't offset our cost as much later in its useful life. A double declining balance rate is determined by doubling the straight line rate. A shortcut to determining the straight line rate is to divide 1 by the number of years. So using the double declining balance method, a 5-year life results in a 40% rate. So the straight line method, 1 over a 5-year useful life equals 20. We multiply that by 2, to get a 40% rate for the double declining balance method. For the first year, the cost of an asset is multiplied by 40% for this example. After the first year, the declining book value of the asset is multiplied by 40%. This requires more math. So we take the beginning cost of it minus the first 40% depreciation. Now we have a new cost. Now we take that new cost minus the 40% depreciation. We get a new cost, so on and so forth. A table is very useful for this. Let's take a look at an example. So year one, our asset, same asset we've been using the example before, $24,000, and we calculated a rate of 40%. So what's our annual depreciation? $24,000 times 40% is $9,600. So our accumulated depreciation, our total depreciation is the $9,600 for that 1 year. Our ending book value is $14,400. Where did we get that from? Our beginning of the year value minus how much we depreciated for the year is the end of year value. That end of year value for year one is our beginning year value for year two. Now we take 40% of that to get the second year depreciation of $5,760. Again, the $14,400 beginning book value times 40% is $5,760. Now we need to figure out the accumulated depreciation. We had $9,600. Now we add this year's depreciation and get $15,360. Our beginning value of our asset minus the total depreciation gives us an ending value of $8,640. You could also take the second year minus that year's depreciation to get the $8,640. Try to finish the chart for the next 3 years. Years 3 and 4 will be easy. Wait on year 5. There's a trick to it. Pause and try that. Here's year 3, here's year 4. Were your calculations correct? Hopefully. We use the same process over and over. For year 5, if we go ahead and calculate that, we have a problem because depreciation stops when the book value equals the residual value. This book value was $1,866 if we continue with the same calculations. But we said it had a residual value of $2,000. We depreciated too much. So when we get to the last year, we have to look and make sure we don't over depreciate. If we take a look at what the depreciation should be, we have our desired ending book value of $2,000 and we work it backwards. The value of the asset at the beginning of the year was $3,110. We want to save $2,000 worth of it because that's what our desired ending value is. So the difference then is $1,100. So the last year we want to make sure we do not over depreciate. If the preceding equipment was purchased and placed into service on October 1st, so we have again October, November, and December, how would we compute that? We take the depreciation for that first year that we calculated. Remember that depreciation was the $9,600 here for the first year. And we take 3/12 of that because we only had 3 out of the 12 months of the year we were using it to get $2,400. The depreciation for the second year would then be $8,640. Where does that come from? We had the $24,000 minus the $2,400 times the 40%. So that's going to adjust depending on the part of the year. It's always going to be subtracting what the depreciation was from the year before. So if you take a look back at your table, you see you're just subtracting this new depreciation amount as opposed to the old one. One more example. Let's try the double declining balance method. We bought it for $125,000 as a residual value of $5,000 and it's useful for 10 years. See if you can calculate the double declining balance rate and the depreciation for the first year. Hopefully you got 20% for the declining balance, double declining balance rate. So 1 out of 10 for the 10-year useful life, and then we multiply that by 2, 20% per year. The $125,000 cost times the 20% per year, that would be $25,000 for the first year. We have a summary of depreciation methods. Pause, take a look at this. It's also Exhibit 6 in your book. It's a great reference. Exhibit 7 is also a great reference looking at the depreciation expense for the different methods and how that varies. Use this as you continue to do your assignments. Those are your notes for today.